Hello students, welcome back to today's class on quadrilaterals. In the previous classes we learned what are triangles or three-sided polygons, and now we are going to discuss about the four-sided polygons that are quadrilaterals. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So first of all, let's try to see what is a quadrilateral, which type of shapes or which type of figures we consider as a quadrilateral. Okay, you can see here. A quadrilateral is a simple closed figure, simply polygon. Okay, simple closed figure, we say that is a polygon. If you can remember the definition of polygon, a simple closed figure, right? Bounded by four line segments in a plane. How many? Four line segments. And now here you need to understand the difference between different polygons. In the previous classes we discussed about triangle, which is a three-sided polygon, 1, 2, 3, which is surrounded or bounded by three line segments. And now we're discussing about a polygon with a four-sided right? So how to structure that, how that quadrilateral will look like. So we have different structures. Triangle, we always have a triangle in this way, okay, based on the side lengths or whatever it is. We say isosceles triangle, equilateral triangle, scalene triangle, and based on the angles also we keep different names for that, right? Equilateral triangle and obtuse, acute angle, right angle triangle. So different names for that. In the same way, based on the different properties the sides have or the angles have, we name them into different structures. Although all these figures are again a closed figures of four segments by four line segments. Okay, so you can see here, if let's say all the sides are equal in this figure, so we say that square. If only opposite sides are equal, we say that as a parallelogram, right? And again, opposite sides are parallel, and these two sides are equal. So based on the different orientation, different properties that sides exhibit, so the angles exhibits, we keep different names for them. And again, whenever we say different figures, sometimes all the sides of that figure may be equal, sometimes may not be. All the angles may be equal, sometimes may not be. Sometimes only opposite angles may be equal, opposite sides are equal. Sometimes nothing will be equal. No side, no angle, nothing will be equal. So based on that, we have different quadrilaterals. Okay, let's try to understand one after that in today's class. We're going to learn what are the different types of quadrilaterals that we are having. Okay, so the first one we're going to discuss about a rectangle. This shape, whatever you're seeing here, okay, the quadrilateral ABCD has four sides. First of all, let's try to understand about some terminology of this quadrilateral. Quadrilateral means a four-sided closed structure or four-sided polygon. The quadrilateral ABCD has four sides: AB, BC, CD and EA. AB, BC, CD and EA. So we have four sides. These four sides are common for all the quadrilaterals. If a quadrilateral is not having four sides, it is not a quadrilateral, it is some other figure. If it is having three sides, we say triangle. 5 sides, pentagon. 6 sides, hexagon. So we have different names for all those. Okay. So now, the quadrilateral ABCD has four sides: AB, BC, CD and EA. AB, BC, CD and EA, and four vertices. What do you mean by vertices? That exact corner points. This corner point, which we write it as A, this is B, this is C, and this is D. These are the four vertices. So a quadrilateral will have four sides, four vertices, and also if you can observe, there is an angle here, there is an angle here, there is an angle here, right? Whatever the angle it is, so we have four angles as well. So for a quadrilateral, we have four sides, correct? Four vertices, again that's correct, as well as four angles, So all these will be in count of four for a quadrilateral. Angle, this is how we represent angle, right? So this is angle A. The measurement here that we obtained is angle B. How to measure the angles, how to write them, that we are going to learn later. Okay, so these are the four angles. Angle A, angle B, angle C and angle D are the four angles formed at the vertices. Angles will form at the vertex. at the vertices. Okay, so we have 4 vertices, 4 sides, 4 angles, and that type of structure we say it is a quadrilateral. Okay, so the next one, when we join the opposite vertices AC and BD. So this is a quadrilateral, you know that. Now I want to join A and C. So we get one line segment here. Let me draw that once again properly. So now we are joining A and C, not A and B, A and C, as well as B and D. So what is this BD? What is this AC called? AC line and AC line segment and BD line segments are called diagonals of a quadrilateral. Okay, so AC and BD are the 2 diagonals of the quadrilateral ABCD. Now the question is, for a quadrilateral, how many diagonals are possible? For a quadrilateral, 1, 2, 3, 4. No, only 2. Which 2? AC and BD. AC or CA, both the same. Again, no need to write it as 2 different diagonals. They are line segments. So again, BD or DA, again that is a line segment. So total we have 2 line segments. Total we have 2 line segments, 2 diagonals. So in a quadrilateral, when we said 4 sides, 4 vertices, 4 angles, but not 4 diagonals, we only have 2 diagonals. And again, based on the properties the diagonals exhibit, whether they are equal or not, whether they are bisect means they divide them into 2 equal parts, both the diagonals. Okay, so based on that also we define a lot of quadrilaterals. Okay, let's try to understand more about this one. Sum of 4 angles of a quadrilateral 360 or 4 right angles. Okay, this is always correct. Sum of 4 angles of a quadrilateral. So what are the 4 angles here? A, B, C, right? So angle A plus angle B plus angle C plus angle D. Sum of all these angles is 360 degrees. Sum of all these angles is 360 degrees or 4 right angle. What do you mean by right angle? I told you in last class, 4 right angles, 4 in 90 degrees, which is again equal to 360 degrees. One right angle is 90 degrees. One right angle is 90 degrees. Okay, so sum of 4 angles of a quadrilateral 3 is 360 degrees or 4 right angles. Okay, next one. So let's try to understand different types of quadrilaterals. As I told you, depending on the structure, depending on the size, depending on the length of sides or the angles, we have different structures. The very first one you can see here. Okay, so what happened here? These 2 sides are parallel. That means out of all the 4 sides, 1 pair or 2 sides are parallel. 2 sides are parallel. AB is parallel to CD. This is a symbol for parallel. Parallel in the sense they are moving in the same direction. Okay, and what about AD and BC? AD and BC are not moving in the same direction, but they are equal in length. Okay, so if AD and BC, AD is equal to BC, then we can say that it is a trapezium. This is called a trapezium. Okay, the quadrilateral ABCD had 1 pair of opposite sides AB and DC, had 1 pair of opposite sides, right? 1 pair of opposite AB and CD parallel to each other. Such a quadrilateral is called trapezium. Such a quadrilateral is called trapezium. If these 2 sides are parallel, it is enough to say that it is a trapezium. But what happens if the sides are also equal? If the sides are also equal, if in a trapezium non-parallel sides are equal, so if these 2 sides are equal, whatever I'm saying here, if AD is equal to BC, then still it is a trapezium, but it is an isosceles trapezium. Okay, we say that as isosceles trapezium. When 2 sides are parallel, it is enough to say that it is a trapezium. How to read that? It is a trapezium. But in that trapezium, if the lines which are not parallel, these 2 lines, if they are equal in length, we can say that it is a trapezium. You can ask me, sir, always do we have AD and BC equal? Not always. You can have a trapezium like this. I'll draw here only. So this one side. Okay, so you can see here these two opposite, this one and this one are not equal. Although these 2 are parallel, the other 2 sides are not equal. So it is just enough to define a trapezium if 1 pair of sides are parallel. But if the other 2 sides are equal, then we can say that it is an isosceles trapezium. We can say that it is an isosceles trapezium. Okay. So moving ahead for the next question. So Yeah, so once again trapezium, let me draw trapezium like this. So this trapezium, which we're not going to discuss now. Now there is some difference between these two. What happened? Here, not only one pair are parallel, the complete, all the sides are parallel, right? All the opposite pairs, these two are parallel as well as these two are parallel. And obviously when these two are parallel, we say that it is a parallelogram. We say that is a parallelogram. If both pairs of opposite sides, of the quadrilateral are parallel, such a quadrilateral is called a parallelogram. If both pairs of opposite sides of the quadrilateral are parallel, such a quadrilateral is called a parallelogram. So here AB, this side length, is parallel to CD. AB is parallel to CD in the same way BC is parallel to AD. BC is parallel to AD. AB is parallel to CD and BC is parallel to AD. If both pairs of opposite sides of the quadrilateral are parallel, such a quadrilateral is called a parallelogram. Okay, so what else we are going to learn next one? So here carefully see that. Once again, let me draw the previous two figures. One, we discussed about trapezium. Right? This is a trapezium. The next one we discussed just now about a parallelogram. Okay, so this is a parallelogram. The next we are going to discuss where although both the sides are parallel, but some other things are there to discuss here. What is that? Parallelogram having all its angles as right angles. You know what is right angle? A perfect L-shaped will give you right angle, right? So this is not an L shape, this is not an L shape, not L shape, not L shape. So parallelogram will not have right angles. But in case if that parallelogram has right angles, we say that as a rectangle. This is one right angle, and right angle. So all its angles as right angles, we say that as a rectangle. Understand? Parallelogram having all its angles as right angles is rectangle. Opposite sides are equal in a rectangle. Okay, opposite sides, that means AB and CD are equal. And BC and AD are equal. Okay, so this is how we try to define rectangle. We discussed about trapezium where one side is parallel, both opposite sides are parallel, we say parallelogram. Opposites are parallel and it is a right angles. We are getting right angles. It is called a rectangle. Still, there are more quadrilaterals that we are going to discuss in today's class. The next one is something like a diamond shape, you can say, which is called a rhombus. Okay, parallelogram having its edges and sides equal. That means edges and sides are equal. The next to next sides are equal is called a rhombus. Okay, so edges and these two sides are equal. So then we can say that it is a rhombus. Edges and not all the sides. That we are going to discuss next. What will happen when all the sides are equal? So it is a rhombus. Okay. So now let's come to that. Parallelogram has its edges and sides equal and angles of 90 degrees. Edges and sides equal and angles of 90 degrees. Right. So this is called a square. So this is right angle, and all the sides are equal. Then we can say that it is a square. What is the difference between the before case? In the before case, when we're discussing about a rhombus, right? Here also all the sides are equal, but the angles are not equal to 90 degrees. Whereas in the next structure, when we're discussing about a square, right? Let me go back to square. Right. When we're discussing about square, edges and sides are equal and angles of 90 degrees. So all the angles are 90 degrees. This is called as a square. All the sides are equal. In a square, AB is equal to BC is equal to CD is equal to DA. All the sides are equal. And all the angles are 90 degrees. This is very important because that point is not correct for a rhombus, but for a square it is correct. Understand? That is the difference between rhombus and square. Next one. Parallelogram has its adjacent sides equal and angles of 90 degrees, the same square. Okay, once again the slide got repeated. Next one. So now I think you can see this shape, which is something like a kite shape. Okay, you know what is a kite, right? So kite, K-I-T, kite shape diagram. Again, it's a four-sided closed structure, which is a polygon, which is a quadrilateral. The quadrilateral ABCD having two pairs of adjacent sides equal. Two pairs of adjacent sides equal. That means this one and this one are equal. This one and this one are equal. Where AB is equal to A, B is equal to AD, and BC is equal to CD. This is called a kite. Okay, so this type of structure is called kite. You know what is a kite, right? So once again, let us try to come back for all the diagrams that we have discussed now. We discussed what is a trapezium. We discussed what is a trapezium, where one side are parallel, opposite sides are parallel. We say it is a parallelogram. We say that is a parallelogram. From there, we also got a rectangle where angles are 90 degrees, rectangle, but not all the sides are equal in rectangle. When all the sides are equal, and all the angles are 90 degrees, we say that is a square. Okay, and this shape, diamond shape, where adjacent sides are equal but not 90 degrees, we say that as a rhombus. And again, from rhombus, now we are discussing about kite shape. Okay, so these are all the different quadrilaterals that we are learning in this chapter. Right. Next one, ABCD is a parallelogram and angle A is equal to 60 degrees. So find the remaining sides. What is this? What is ABCD? ABCD is a parallelogram. Angle A, this value is given as 60 degrees. Angle A is given as 60 degrees. The question is, find the remaining angles. So how to find this one? We need to find the remaining angles. Can you carefully observe? In a quadrilateral, the very first one you need to understand is sum of the adjacent sides is 180. Sum of the adjacent sides, that means angle A plus angle B should be 180 degrees. Sum of the adjacent sides should be equal. I mean, sum of the adjacent angles should be 180 degrees. 180 degrees. Okay. So 60 plus angle B is 180. So angle B is equal to 180 minus 60, which is a 120. Angle C is 120. Angle B, once again, it's angle B, right? Angle B is 120. In the same way as we have discussed now, if you consider that adjacent angle is D, right? So these two should be again 180. So this is again 120, and again 120 plus some number should be 180. So again it is a 60. So in a parallelogram, if you have one side is 60, one angle is 60, the other angle will be 120, the other angle is 60 again, the other angle is 120 again. This is how the pattern will look like. Okay. Let's go for one more approach of the same concept. Two adjacent sides of a parallelogram are 4.5 centimeters and 3 centimeters. So find its perimeter. What is that happening here? Two adjacent sides of a parallelogram are 4.5 and 3 centimeters. Carefully see here. 4.5 parallelogram. One is 4.5 centimeters, other is 3 centimeters. Now, the question is to find its perimeter. What do you mean by perimeter? Perimeter is the sum of all the sides. How many number of sides it may be? It may have 10 sides, 20 sides, 100 sides, whatever it is. Sum of all the lengths of all those sides will give you perimeter. We are not discussing about area. Don't forget or don't confuse between perimeter and area. Right? So now one side is 4.5, other side is 3 centimeters. Again, these two are equal. I said you in parallelogram, these two will be equal. So this again 4.5 centimeters and this is again 3 centimeters. That is again 3 centimeters. Okay. So now let's try to find the perimeter, which is a 4.5 plus 3 plus 4.5 and again plus 3. 4.5 plus 3 is 7.5. 7.5 plus 7.5 will give you 15 perimeters, 15 centimeters. Okay, so 4.5, 9 plus 3, 12, 12 plus 3, 15. So that is the perimeter of this parallelogram. Perimeter means always sum of all the sides. Perimeter means sum of all the sides. Right. What else we are having? Next one. Two adjacent sides of a parallelogram are 4.5 and 3 centimeters. Find its perimeter. The same question again. Okay, the same question again. The next one. Okay, let's try to discuss once again about all the quadrilaterals that we have discussed in today's class. So, what the first one that we are going to discuss is a trapezium. We have discussed about trapezium. Once again, let me write all this trapezium, where if you can remember, only one pair of opposite sides are equal or parallel, so not equal, parallel. Once one pair of opposite sides are parallel, let me name that A, B, C, D. So we can say that AB is equal to CD. We can say that AB is equal to CD, right? In the same way, we have parallelogram. We have parallelogram where these two sides are parallel as well as these two sides are parallel and they are equal. I mean, these two opposite sides are equal, these two opposite sides are equal. So A, B, C, D, we can say that AB will be equal to CD and BC will be equal to AD, right? And from the parallelogram only, where two sides are, the opposite sides are parallel, we came to conclusion of what is rectangle, what is a square, what is a rhombus, what is a kite, right? So all this came from the basic structure called parallelogram, right? So coming to that and more in detail specifications as well as properties of all these quadrilaterals that we're going to cover in the next class, right? So I hope you enjoyed this lecture about all the quadrilaterals. In the coming class, we're going to discuss some more applications based on all this, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So now we'll be discussing about center of gravity. Okay. So my name is Shashin Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. So first of all, have you any time tried this? I mean, it's dangerous. So without proper experience, without proper practice, we don't do this. But we see that in circus, right? We can see it. We can watch people doing this in circus. They balance themselves. But forget about that. Even we can do something like this, not on a rope, but on a thin wall. Okay, let's say on a wall, you're walking on a wall. Then you keep your hands to the side and try to balance. What are you trying to balance? Obviously, so that you will not fall down. But what are you trying to do by balancing? Right, that's the question. Right. So beyond this, so this balancing act happens because of one point called as center of gravity. That's what we'll be discussing in today's class. So before we go into that, again another simple everyday life question. You would have done this many times. So to balance a meter ruler, when I say meter ruler, it's a scale. Okay, meter is 1 meter long and we have a scale. So 1 meter scale. So to balance it, where should you support it using your finger? Where should you place your finger? That is a question. Yeah, where everyone? If you want to, it's like this, balancing a pen on your finger. You can do that, right? Yes, it's possible. Now I'm placing my finger here. The same way, if I have a meter long scale, where should I place my finger so that we can balance it? Where? A meter ruler. So what is its length? Its length is meter. So generally what we do is, generally we have to place the finger where? At the center. Generally we have to place the finger where? At the center. We know it. We know that from our experience. Yes. So place it at the center. At the center. And when I say 1 meter, here you'll have 0. And 1 meter is 100 centimeter. So what is the center? The center would be at 50 centimeter mark. Yes, between 0 and 100, the center is 50 centimeters. So at the center, or you can say near the 50 centimeter mark, if you place your finger, you will be able to balance the scale. Yes? Good. So what exactly is at that point? Now why should you place your finger only exactly at the center? Why can't you place it at 100, at 0, or at 40, or at 60, or at 70? Why exactly at 50 centimeter? Because that is where a point called center of gravity lies. That's where a point called center of gravity lies. What is that center of gravity? So look at this. A solid body can be horizontally balanced by only supporting it at a point called as center of gravity. So as we discussed, for that scale, the center of gravity will be at its center. Okay. So what is that? So that is the point where we can assume that the total weight acts. When you balance something, You have to balance it in such a way that you balance the weight. You balance the weight. So center of gravity is that point where you can assume that the complete weight of the body acts. So the point where total weight appears to act is called center of gravity. The total weight will appear to act. So what does total weight appear to act mean? I'll show you something. Let's say this is a random object. And when I say random object, there are many particles, many particles. It's made up of particles. So here if I take a small particle, on that particle, this particle will have some mass, let's call it as m1. So on it, will there be weight? Yes, there will be weight. Weight will be m1g. If I take any other particle here, let's say its mass is m2. Will there be weight? Yes, there will be weight. Gravitational force. If you have mass, there will be weight, right? If I take another mass m3 here, there will be again m3g. Here if I take a mass m4, let's say m4, there also it will be a mass m4g, right? Weight will be there. So the gravitational force, which we call as weight, will be acting at every point. The gravitational force, which we call as weight, will be acting at every point. But that is the reason why we say the total weight appears to act. It's not exactly acting at that point. It will appear to act at that point, and that point is called as center of gravity. So for this scale, here there is weight, everywhere there will be weight acting. But we can say that the total weight will act at its center, and there we have to place what? We have to place our finger. And center of gravity, normally the symbol is capital G. So when we say capital G, it will refer to what? Center of gravity. It is the point where the total weight can be assumed to act. Good? Okay. Now as we understood, if I take the example of a rod and I'll take the example of a uniform rod, like a scale. So it's uniform everywhere. Uniform in the sense same everywhere. It's not like this. It is not like this. Is it uniform? This is not uniform. Non-uniform. This is non-uniform. Right? Uniform in the sense it is the same everywhere. Its density will be equal everywhere. This density will be equal everywhere. So if I take a uniform rod, uniform is the keyword. Uniform is important. So if I take a uniform rod, it's like a scale. If you take a scale, where will you balance it? At the center. So where is the center of gravity? At the center. So here the center of gravity for a uniform rod will be at the center of the rod, and that's where the center of gravity is going to be. It's just a point. It is just a point on the rod. Clear? Good. Similarly, we have other shapes. Not only a rod, we have many other shapes. We have a ring for an example. If I take ring for an example, this, let's say it is a ring. Okay. So for a ring, where will it be? It will be at this center. For a disc also, where will it be? For a disc, also it will be at the center. Got it? So for both the shapes, for a ring as well as a disc, for a circular ring and for a circular disc. Simple enough. But the interesting point regarding a ring is the center of gravity inside the ring or outside the ring? Or let's say, better question, on the ring or not? Is center of gravity on the ring? Is center of gravity on the ring? When I say on the ring, it should be here. Right? On the ring will mean wherever I am drawing the blue dots. These points will mean on the ring. But here you can clearly see that the center of gravity is at the center, and at the center, do you have any mass? Is there any material of the ring at the center? No. That means these blue dots represent inside the body, and anything outside it is outside. So your center of gravity is outside the ring. Center of gravity is outside the ring. Got it? Good. So from this we can say that center of gravity can also be where? Can also be outside the body. Here it is inside the body. If there is mass, it means it is inside. Here there is no mass at center of gravity, that means it is outside the body. So keeping that in mind, we have a few properties for center of gravity. What are they? First of all, the position of center of gravity depends on shape of the object. Pretty simple. We have looked at two shapes, in fact 3 shapes. One is a ring, a disc and a rod. For a rod and for a ring, we could easily understand that it depends on the shape of the object. Yes. And center of gravity need not necessarily be within the material of the body. Example, a ring. See that within the material, it's outside the material, where there is no mass. Right? So this is a very important point. Center of gravity can be outside the material of the substance also. Got it? Good. And another interesting point is, a body of weight W can be considered as a point particle of the same weight at its center of gravity. What does this point mean? Now this is only for calculation purposes. Okay, it's just a point. So if the body is like this and center of gravity is this can be assumed to be only a single point of the same weight. Okay, single point of the same weight. We will not be using it much. It's just a point, and we use it in calculations, force calculations and all. But yeah, not required that much as of now. But again, it's an important point. Alright, so 3 important properties of what? Center of gravity. And we have many other shapes, as we know. Right, some of the shapes are given here and the center of gravity positions are also given. The shapes that we already discussed are rod and circular ring and disc. And there are other shapes. We'll go into them and again come back to the table. Got it? So here we have what? A triangle, and we call it as a triangular lamina. What does a triangular lamina mean? When I say that this is a triangle made up of 3 rods, this is not triangular lamina. If we need the inside to be filled, okay, you can take a paper, cut a paper in the shape of a triangle. It is a triangular lamina because its inside is filled with the material. Right, so this is completely filled with material. This is completely filled with material. That's what we are talking about. And for a triangle, for a triangular lamina, lamina will mean a 2D object. Understand this, lamina is not 1D, lamina will mean 2D object. So when we take a triangular lamina, the center of gravity will be at the centroid. Wherever the centroid is, there you'll have what? Center of gravity. And how do you find the centroid? That's part of maths, you should know it. Wherever the medians meet. Wherever the medians meet, that is what? That is centroid. Got it? Good. Then again we also have a cylinder. You can take a hollow cylinder or a solid cylinder, it doesn't matter. What you will do is, from the center, there will be a line, yes or no? This we call as axis of cylinder. And on the axis of cylinder, exactly at the center, capital G. That is, if the complete height is h, complete height of cylinder or length of cylinder, whatever you call it, if it is h, then from the top or from the bottom, it is exactly at a height of h by 2. Got it? H by 2. It's completely h, and here it is h by 2 and h by 2. Understood? Simple as that. Clear? Good. So this is for a triangular lamina and this is for a cylinder. Then we also have another shapes, rectangle. For rectangle, what will we do? Simple, intersection of diagonals. Wherever the diagonals meet. Even for a parallelogram, it is same, we need not be confused. Wherever the diagonals meet, that is where the centroid will be. Okay, there are some points that we just have to remember, that's it. So how did we get this? Are there any method to derive it? There are methods to derive it. There are experimental methods to find them. Okay, there are many other methods. But for now, please Just remember them. Okay. The shapes are given here: ring, disc, lamina, rectangle, parallelogram, square, rod and cylinder. And all of them are discussed here also. You can go through them. Got it? Okay, so these are some regular shapes that we discussed until now. Regular shapes, like the shapes that we know, which have a definition, proper definition. But if I take this shape, what is that shape? What is this shape? It's a completely random shape. It's a completely random shape. Yes or no? Right. So, for these random shaped objects, how do you find the what? How do you find the center of gravity? For random shaped objects, how do you find the center of gravity? Again, there's a very interesting and a very simple method for that. You can always do it. Okay, so what is that method? I'll show it to you. So what you'll do is, before that, understand this. Again, I'll come back to the word lamina. What does lamina mean? Lamina will mean a 2D object. When I say 2D object, it's a plane object. And when I say plane object, it has negligible thickness. It has negligible thickness, like a paper. Like a paper. A paper which is not crushed. Its thickness is 0, or not 0, negligible, very less. So you can call that as a plane object or a lamina. Good? Okay. So when you take an irregular lamina, an irregular shaped 2D object, then if you suspend it like this way, this is what? This is the point of suspension. So it's like you're making a hole and just hanging it there. You're making a hole in the object and like hanging it to the nail, so that you can just move it towards left or right. It can oscillate, obviously, right? It can move towards left or right like a pendulum. So you're just hanging it, like hanging a shed on what? On a hanger. The shed can oscillate, yes or no? The same way, if you make a hole and hang it or suspend it, it will move and ultimately settle down. It will ultimately settle down. But the point is, it will settle down in such a way that the center of gravity will be where? Will be exactly below the point of suspension. As a C or G. Center of gravity will be exactly below, vertically below the point of suspension. Weight does it. Weight does that. Okay. So you can look at this. Any object suspended from a point finally settles in such a way that, or in a way such that, the center of gravity is directly below the point of suspension. It is directly below the point of suspension. Very important point, because this point will help us in finding out center of gravity of random shapes. Yes. Got it? And you can use this link for simulation. I'll leave it to you, so please do it. Okay. Now, I'll explain how to find out the center of gravity of irregular laminas. You can see that this is one shape, right? And this is an irregular shape, right? So how do we find the center of gravity? It's very simple. First, the shape is something like this, right? Make 3 holes. One hole is made here, I'll call it as A. The other hole is made somewhere here, I'll call it as B. And the other hole is made somewhere here, I'll call it as C. So make 3 random holes. Make 3 random holes on the irregular shaped lamina and suspend it like this. So first you suspend from point A. Now when you suspend from point A, that object will oscillate, will go, will move, finally settle down. When it settles down, draw a vertical line. Then at B, just do the same thing. Again, remove the object, suspend it from another point, let's say B. It will oscillate, it will finally settle down. When it settles down, again draw a vertical line. Remember, the line should be vertical, exactly vertical. Don't draw it left or right, no. Draw it exactly vertical. Then again do the same at C also. Suspend it at C. Let it settle down. When it settles down, draw a vertical line. And after that, wherever the lines meet, that point will be what? That point will be center of gravity, capital G. Wherever the lines meet, that point will be what? Center of gravity, capital G. Simple method, right? Very simple. Very practical one and a very simple method. Yes? So look at this. Make 3 holes A, B and C anywhere on the lamina, 2D object. Suspend the lamina from one hole, say A. When the lamina is settled, draw a straight line vertically downwards using a plumb line. Now what is this plumb line? Now if you go to any construction site, I'll show the plumb line. You will see something like this. It's just a heavy object. You can clearly see that here. It's a heavy object. Heavy object. And how is that heavy object? It is suspended. You can clearly see that heavy object is suspended using a thread. Okay, so when you do it that way, the thread will be exactly vertically down. The thread will be vertically down. So if you use this, you can draw what? A vertical straight line can be drawn using a plumb line. And in construction sites, it is used very regularly. Very easily it is used for many purposes to see the vertical. This is what this is a plumb line. Plumb line that's used to draw vertical lines. See here. Plumb line. Got it? Good. So then repeat the process for all the 3 holes A, B and C. And the point of intersection of all the lines is the center of gravity of the lamina. Very simple, right? Very simple. And why is that? Because see, we know that when a body is suspended, its center of gravity will be where? Will be below or exactly or vertically below the point of suspension. So if I draw a line vertically down, center of gravity should be on that line. The same happens at B also. If I draw a vertical line down, then the center of gravity should be there. Will be on that line. Right, center of gravity will be on that line. And there cannot be multiple center of gravities, only one. So for all the 3 lines, there should be only one center of gravity. That means it is possible only where they meet. Only where they meet, and hence that's where center of gravity is found. Is that clear? Good. That's how you find center of gravity of irregular lamina. Okay, so that's it everyone. We learned about what? Center of gravity of regular shapes and irregular shapes also. So thank you. Thanks a lot.